Okay, let's get started. First thing we want to do is figure out what is and is not a polynomial. Okay, so looking at A, I have monomials that are separated by a plus and a minus, and I have all of my exponents are integers, so this is a polynomial. So what kind of polynomial is it? Well, first of all, it's a trinomial because it has 3 terms. A monomial has 1 term, binomial has 2 terms, trinomial has 3 terms. Next, we want to state its degree. So the degree of the 4x squared is 2. This is technically 3x to the 1, so the degree of that term is 1. I technically have an x to the 0 there, so the degree of that is 0. So this is a second degree. We look at the degree of each monomial and we take the largest one. So we don't add them together. Biggest one I see is 2. This is a second degree trinomial. Okay, B is not a polynomial because it has a negative exponent. Looking at C, it is also not a polynomial because it has a variable exponent. So you can't have a negative exponent. You also can't have a variable exponent. Why is it important to know the degree of the polynomial? Because it tells you the shape of the polynomial. So it tells the shape of the polynomial. It tells me what my end behavior looks like. Okay, it tells me how many maximum and minimums I have. Polynomial, can't spell, nomial. Okay, so it tells you the shape of the polynomial. Okay, so now we're going to practice adding. Okay, so when I add my polynomials, I just rewrite them without the parentheses. So 5d to the 4th plus 8d to the 8th minus 3d squared plus d cubed minus 6d to the 8th plus 5d squared. Okay, so I'm going to look for my highest degree. My highest degree is d to the 8th. So I have 5d to the 8th minus 6d to the 8th is 2d to the 8th. Now once I've added it, I cross it out. Now I'm going to look for my next biggest one is 4th. So I have 5d to the 4th. There are no other d's to the 4th. Now I'm going to cross that out. I have 1d cubed. So I'm going to do 2d cubed. Then I have 2d squared, so negative 3 plus 5 is plus 2d squared. So make sure that you rewrite your polynomial and make sure that you cross out as you use things so you know if you've left something out. Okay, now subtraction, you need to be really careful. I always rewrite my polynomial, so the first one I'm going to rewrite just like I see it. The second one, I'm going to show you 2 ways to do this. There's technically a negative 1 there. So negative 1 times minus 2x is minus 2x squared. It'll be minus 2x squared. Minus 1 times minus xy is plus xy. And minus 1 times plus 5y squared is minus 5y squared. Okay, so always write this second step. Now I'm going to collect terms. I like to go in alphabetical order, so I'm going to do my x squareds first. So 15x squared minus 2x squared is 13x squared. Now I'm going to do my xy's. So minus 2xy plus xy is minus xy. Now I'm going to do my y squared. So minus 2y squared minus 5y squared is minus 7y squared. Now I'm going to show you a slightly different way to do subtraction. They both work, so whichever way you like, go for it. So I'm going to rewrite my first polynomial, 2.3r squared plus 5.8r minus 13.8. Now instead of distributing the negative 1, I'm just going to look at this polynomial and change the sign of everything inside there. So negative 0.4r squared becomes positive, positive 2.7r becomes negative, and negative 2.9 becomes positive. Now I'm going to add my like terms. So 2.3r squared plus 0.4r squared is 2.7r squared. Cross them out. 5.8r minus 2.7r is 3.1r. And then negative 13.8 plus 2.9 is minus 10.9. All right, so you really ought to try this one by yourself. Pause and try it, and then unpause and watch what I do. So I have x. Now I'm going to distribute this 3. So 3 times 3x is plus 9x. 3 times 7 is plus 21. Here I'm going to change the sign of everything in the second polynomial, so that becomes minus 11x minus 2. Now I'm going to collect like terms. X plus 9x is 10x. 10x minus 11x is minus x. Now I have 21 minus 2, and I have, that becomes plus 19. So if I cross out all the ones that are underlined, I can tell that I've used all of my terms. Okay, now with fractions, I'm going to show you two things. So I'm going to show you how to do it the purest way, which is to actually find common denominators and do this by hand. So first I'm going to collect like terms. So I have 1/5 v squared plus 1/3 v squared. Then I have minus 3/4 plus 2/5. So common denominator for 3 and 5 is 15. So I'm going to multiply this, whoops, by 3 over 3. I'm going to multiply this by 5 over 5. So I get 3/15 v squared plus 5/15 v squared. Add those two together and I get 8/15 v squared. Now I'm going to do these fractions. Common denominator here is 20. So I'm going to multiply that by 5 over 5 and this by 4 over 4. So I get minus 15 over 20 plus 8 over 20, and minus 15 plus 8, oops, is minus 7. So I have minus 7 over 20. Okay, now we're going to do some geometry. Okay, so I have a triangle RST. The length of RS is 5x cubed minus 7x squared plus 9. ST is x cubed minus 5x squared plus 1. And RT is 9x cubed minus 5. Now, if I showed you a triangle and said the three sides were 2, 3, and 4, what's the perimeter? What would you do? You would add the three sides together to get 9, and so we're going to do exactly the same thing. We're going to add the three sides together. So I get 5x cubed minus 7x squared plus 9 plus x cubed minus 5x squared plus 1 plus 9x cubed minus 5. Okay, so first thing I'm going to do is my x cubed. So 5x cubed plus x cubed is 6x cubed. 6x cubed plus 9x cubed is 15x cubed. Okay, now I have x squared. So I have minus 7x squared minus 5x squared is minus 12x squared. Cross them out. Now I'm going to add my constants. 9 plus 1 is 10. Minus 5 is plus 5. Okay, so I have a line. The length of the entire line is 3x squared minus 2x plus 2. The length of AB is 8x squared plus 5, and the length of CD is 3x squared plus 2x plus 5. Okay, so if I gave you this problem and asked you what is the length of BC, what would you do? You would say the whole line is 10, so you would subtract 2 and 3, which would give me 5. So then I would know A equals 5. Well, we're going to do exactly the same thing here. We're going to take the entire length of the line and we're going to subtract the other two lengths. Okay, so I'm going to rewrite it with the correct signs. So I have 3x squared minus 2x plus 2. Then I change the sign of both of these, change the sign of all of these, and now I'm going to collect like terms. So 3x squared minus 8x squared is minus 5x squared, minus 5 minus 3 is minus 8x squared. Okay, now I'm going to do my x's. Minus 2x is minus 4x. Now I'm going to do my constants. 2 minus 5 is minus 3. Minus 3 minus 5 is minus 8. And I've crossed everything off. Yay! Okay, now let's practice doing some polynomials, multiplication. Okay, so right here, a lot of people look at this and say this is 4x squared plus 25. Not. Okay, why not? Because technically this means 2x minus 5 times 2x minus 5. So 2x times 2x is 4x squared. 2x times minus 5 is minus 10x. Minus 5 times 2x is minus 10x. Minus 5 is plus 25. Add my like terms and I get 4x squared minus 20x plus 25. Okay, here I get x times x is x squared. X times plus 7 is plus 7x. Minus 5 times x is minus 5x. Minus 5 times 7 is minus 35. So I get x squared plus 2x minus 35. This one I get x times x is x squared. X times 7 is minus 7x. 5 times x is plus 5x. And 5 times negative 7 is minus 35. So now I get x squared minus 2x minus 35. So you'll notice that those have the same numbers but different signs. So you do need to be careful and watch your signs when you're doing this. Okay, so for this one, I get 2x times x is 2x squared. 2x times minus 6 is minus 12x. 1 times x is plus 1x, and 1 times minus 6 is minus 6. So I get 2x squared minus 11x. Minus 6. Okay, here 2x times x is 2x squared. 2x minus 2 is minus 4x. 3 times x is 3x, and 3 times minus 2 is minus 6. Combine my like terms and I get 2x squared minus x minus 6. Okay, here I get 4x times x is 4x squared. 4x times 5 is plus 20x. Minus 5x times x is minus 5x. And minus 5 times plus 5 is minus 25. So I get 4x squared plus 15x minus 25. Okay, one more set. Bear with me. Okay, here I get x times 6x is 6x squared. X times negative 1 is minus x. Negative 15x minus 6x is minus 90x. And negative 15 times negative 1 is plus 15. So I get 6x squared minus 91x plus 15. Okay, here I get 2x times 2x is 4x squared. 2x times 5 is 10x. Negative 5 times 2x is minus 10x. And negative 5 times 5 is plus 25. Now, when I combine my like terms, 10x minus 10x is 0. So I get 4x squared plus 25. Now, we have some, this is technically the difference of two squares, where 2x would be a minus b, and then this would be a plus b. So if you recognize that as the difference of two squares, we know that the difference of two squares equals a squared minus b squared. So if a is 2x, that would be 2x squared, and b is 5. So that would be 4x squared minus 25. Okay? Oh, whoops. Haha, caught an error. That should have been a minus. Sorry. That should be a minus. So I'm glad I did it both ways. Sorry. Okay, so moving on. Okay, right here I get 4x times x is 4x squared. 4x minus 25 is minus 100x. Minus 1 times x is minus x, and minus 1 times minus 25 is plus 25. Combine my like terms, I get 4x squared minus 101x plus 25. Okay, now I'm going to distribute this a, that's technically a to the 1. This is technically a to the 1, b to the 1, so now I'm going to distribute. So a times 2a squared is 2a cubed, 1 plus 2 is 3. A times 3ab is plus 3a squared b, and a times b squared is plus ab squared. Now, these are not like terms. Sorry, let me rewrite this a little neater. Okay, these are not like terms. Okay, both of these terms have an a and a b. They both have an exponent of 1 and 2, but they're not exactly alike. So those are not like terms, so I am done. Okay, now we're going to throw in a negative. So negative x, y times x squared y. These are both exponents of 1, so I get negative x cubed y squared. Negative xy times that is minus 2x squared y. Negative xy times 5y squared is plus 5x y cubed. Okay, now, when I do a binomial times a trinomial, I like to use a box. I think I make less mistakes when I use a box. If you don't want to do it this way, you can do double distribution, and that's fine, but I'm going to do it this way. Okay, so 2p times p squared is 2p cubed. 2p times p is 2p squared. 2p times minus 2r is minus 4rp. R times p squared is rp squared. R times p is rp. And r times minus 2r is minus 2r squared. I only have one cubed term. Ken's being weird today, sorry. Okay, so I have one cubed term, 2p cubed. I have one p squared term, so plus 2p squared. Now I have two rp terms, so minus 4rp plus 1 rp is minus 3rp. So I've used that. Now I have 1 rp squared minus 2r squared. Okay, so we've written this hopefully in kind of correct notation. This is not one where we would count off if you put them in the wrong order. Whoops. Okay. Okay, now we're going to do this one. 2y times 6y squared is 12y cubed. 2y times minus 3 is minus 6y. 2 times 6y squared is plus 12y squared. And 2 times minus 3 is minus 6. Okay, so I'm going to rewrite this in proper order. 12y cubed minus 12. Is that a plus? That's actually a plus, isn't it? Okay, sorry, that's a plus. Yes. Okay, so plus 12y squared minus 6y minus 6. Okay, now we're going to do some more geometry. Okay, so I have a rectangle, okay, so which has a length and a width. The length of the rectangle is 6 units less than 5 times the width. So we want the area of the rectangle, which is length times width in terms of width. So I have 5w minus 6 times w, which would be 5w squared minus 6w. Normally we have units, like centimeters or inches, so we're just going to say units this time. Okay, so I have another rectangle, length and width. My length is 2x plus 1. My width is 5x minus 4. So my area, which is length times width, would be 2x plus 1 times 5x minus 4. So 2x times 5x is 10x squared. 2x times minus 4 is minus 8x. 1 times 5x is plus 5x. And 1 times minus 4 is minus 4. So I get 10x squared minus 3x minus 4, technically units. Okay, so trapezoid. Okay, the height of my trapezoid is x plus 2. The length of line segment AB is 2x plus 1. And the length of line segment DC is 8x. The area of a trapezoid is 1/2 height times B1 plus B2. So this area is 1/2 times the height times the bases added together. So I have 1/2. Now I don't want to deal with fractions, okay? So I'm going to multiply by my polynomials first. Now this polynomial simplifies to 10x plus 1. So I'm going to go ahead and multiply out these first. So I get 1/2 times x times 10x is 10x squared. X times 1 is x. 2 times 10x is plus 20x. And 2 times 1 is plus 2. Okay, so simplifying, I get 10x squared plus 21x plus 2. So multiply by 1/2 and I get 5x squared plus 21 over 2x plus 1, and this would be units squared. So centimeters squared, inches squared, whatever my units were. Okay, now we're going to do a triangle. Okay, so I have triangle A, B, C. The height of the triangle is 5b minus 1. The base of the triangle is 2b plus 2. Area of a triangle is 1/2 base times height. So that would be 1/2 times the base times the height. So once again, I like to multiply this first. So I have 1/2 times 2b times 5b is 10b squared. 2b times -1 is minus 2b. 2 times 5b is plus 10b, and 2 times -1 is minus 2. So that becomes 10b squared plus 8b minus 2. 1/2 times 10 is 5. 1/2 times 8 is 4. And 1/2 times minus 2 is minus 1. Now technically, we could have done 1/2 times 2b plus 2 first, so whichever way you want to do it works great. Okay, now we're going to find some quotients. I think the easiest way to do quotients is to separate these into two different monomials. Okay, now you can only separate the numerator, you can't separate the denominator. So here I have 4y over 4 plus 15z over 4. My 4's cancel out and I get a y. 15 over 4 doesn't reduce, so I have 15 over 4z. Okay, now let's try a harder one. We'll add some negatives and variables. So once again, I'm going to separate it into 2, and I get minus 24x squared over minus 4x. Here I get plus 18x over negative 4x. So negative 24 over negative 4 is positive 6. X squared over x to the 1 is x. Here, a positive over a negative is a negative, so I'm going to change this to a subtraction sign. 2 goes into 18 9 times. It goes into 4 twice. So I get minus 9 halves, and my x's cancel out. Okay, now we're going to do one even more complicated, but I have complete confidence in you. Okay, so here I have 5x to the 5th y squared over 5x cubed y. Here I have minus 30x cubed y to the 6th over 5x cubed y. Okay, so my 5's cancel out. X to the 5th over x cubed is x squared. 5 minus 3 is 2. This is technically y squared over y to the 1st, which is y. Here, 30 over 5 reduces to 6. My x cubes cancel out. And y to the 6th over y to the 1 is y to the 5th. Okay, so I've already gone ahead and drawn this picture. I have triangle ABCD. The area of the triangle is this. Side AB is 3x. So the area of a triangle is length times width. We're measuring a length. So if I solve this for length, I get length equals area over width. Okay, so my area is 6x cubed plus 9x squared minus 15x all over 3x. So now I can separate this into 3 terms. 6x cubed over 3x plus 9x squared over 3x minus 15x over 3x. Okay, so 6 over 3 is 2. X cubed over x to the 1 is x squared. 9 over 3 is 3. X squared over x to the 1 is x. 15 over 3 is 5, and my x's cancel out. Okay, so here we have a combined pool and deck. Okay, so the length of the combined pool and deck is 5x plus 2, and the width is x plus 5. Probably should have put them in different places, but we're going with it. Okay, so the length of the pool, the corresponding length of the pool would be x plus 3. The length of the other side of the pool would be 4x plus 1. Okay, so first thing we want to do is write a polynomial for the area of the pool plus the deck. Okay, so that would be x plus 5 times 5x plus 2. So x times 5x is 5x squared. X times 2 is plus 2x. 5 times 5x is plus 25x. And 5 times 2 is 10. So that gives me 5x squared plus 27x. Whoops, hard to read, sorry. So 5x squared plus 27x plus 10. Okay, now I'm going to do the area of just the pool. Okay, so this little part is just the pool. So the area of the pool is x plus 3 over 4x plus 1. So x times 4x is 4x squared. X times 1 is x. 3 times 4x is plus 12x. And 3 times 1 is 3. So that gives me 4x squared plus 13x plus 3. So the area of the deck, is going to be the total area minus the pool area, which is 5x squared plus 27x plus 10 minus this. So I'm going to change the sign on each of those. So minus 4x squared minus 13x minus 3. Now I'm going to collect like terms. So 5x squared minus 4x squared is x squared. 27x minus 13x is plus 14x. And 10 minus 3 is 7. Okay. Now we have a bunt pan. So we have a pan. Okay, so it's a three-dimensional. That is a really bad picture. Holy moly. Okay, I'm going to do that again. Sorry. Okay, so I have a pan with a length, a width, and a height. Okay, so I have 2x by 3x by 5x plus 1. So volume is length times width times height. So that's going to be 2x times 3x times 5x plus 1. So 2x times 6x, 2x times 3x is 6x squared. So 6x squared times 5x is 30x cubed. 6x squared plus 1 is 6x squared. So the volume is 30x cubed plus 6x squared. Now, let me write that up here. So 30x cubed plus 6x squared. Now, whoops, that's okay. Okay, so it was, my volume was 30x cubed plus 6x squared. I want to know what is V of 2. So that means I'm going to put 2 in for x. So I have 30 times 2 cubed plus 6 times 2 squared. 2 cubed is 8. 2 squared is 4. So I get 240 plus 24, which is 264 units squared. Okay, so volume should always have units. Okay, now we're going to do some review problems. Okay, so domain is the set of all x's. Range is the set of all y's. So for A, the domain would be -9, -4, -3, -2. Some people like to list them just like they're listed. I like to list them in order from smallest to largest. Either way is right, it doesn't really matter. So my range is going to be 5, 7, and 9. Okay? All right, now I don't, even though 5 appears twice, I don't put that in the range twice. Okay, domain for B is -2 and 4. Again, I don't list the -2 twice. And the range is 5, 6, and 9. Okay, now we want to know which one is a function. So a function is when we do not have repeated x's. So we do not have any repeated x's in A. We do have repeated y's, but that doesn't matter. So this is a function. Okay, in B, I have the -2's are repeated. So this is not a function. Okay, now we're going to write the equation of line and slope-intercept form that goes through these points. So we're assuming since this is a line that all 3 of the points are there, We only need 2 points to actually write the equation on the line, and I choose these because there's no negatives. So my slope is y2 minus y1 over x2 minus x1. Okay, so I'm going to call this x2, y2. I'm going to call this x1, y1. So y2 is 5, y1 is 4, x2 is 0. So I get 1 over negative 2, which is negative 1/2. So that's my slope. Now it wants it in slope-intercept form, which is y equals mx plus b. Now, what do I know about this point 0,5? The x-coordinate of the y-intercept is 0, so 5 is technically the y-intercept. So I can just go ahead and write my line, y equals negative 1/2 x plus 5. Now, if the y-intercept was not there, I would have to start off in point-slope form and rearrange to get to slope-intercept form. Okay, now I want to write the following expressions with positive exponents. Okay, so if I have negative exponents and my monomial is not written as a fraction, I'm going to write it as a fraction. So this is 2x cubed y to the minus 6, and I'm going to make that a fraction. So everything that has a positive exponent stays where it is. Everything that has a negative exponent moves. So 2 to the first power is going to stay where it is. X cubed is going to stay where it is. Y to the negative 6 moves down and becomes positive. Okay, so right here, 2 over 4 reduces to 1/2. A squared over a to the 1 is a to the 1. B cubed over b squared is b to the negative 1. Now I need to get rid of my negatives. My 1/2 stays where it is. A to the 1 stays where it is, and I don't technically, oh, is that a 4? That's a 4. Huh, okay. So, so that's a minus 4. So 2 minus a minus 4, that should actually be a 6, sorry. Okay. And then that's still negative 1, right? No, negative 3, that's a positive 2, so that should be minus 5. Boy, Ms. Stoltz is off her game on this one, huh? Okay, sorry, I tell you what, let's just start it over so we're not confused. Sorry. Okay, so that's that blue line, I can't see what's going on, sorry. So 2 over 4 reduces to 1/2. This is a minus 4. Okay, so this is a minus 4, so 2 minus a minus 4 is a to the 6th, and b minus 3 minus 2 is b to the minus 5th. So now 1/2 stays where it is, a to the 6th stays where it is, and b to the negative 5 moves down. Okay, sorry about that, guys. Okay, so this one, negative 60 over 18 reduces to negative 10 over 3. The 6 goes into 60. 6 goes into 60. Yeah. Okay, 6 goes into 60 negative 10 times, and 6 goes into 18 3 times. So x to the 0 minus 3 is x to the minus 3. Y to the negative 6 minus 0 is y to the minus 6. Okay, so now my minus 10/3 stays where it is. This is not a negative exponent, that's a negative number. So the 10 stays where it is. X cubed moves down, y to the 6 moves down. Okay, so now we're going to practice our function notation. F of negative 4 means I'm going to plug negative 4 in every place I see x. So I get negative 3 times negative 4 plus 10. Negative times a negative is a positive, so that's 12 plus 10, which is 22. Okay, f of 2/3. I have negative 3 times 2/3 plus 10. So negative 3 over 1 times 2/3 gives me negative 6 over 3, which is negative 2, and negative 2 plus 10 is 8. Okay, now we want to graph a line that goes through the point 1, 2, and is perpendicular to this line. So first I'm going to plot the point 1, 2. Now to find the slope of the line, okay, that's perpendicular to this, I first have to find the slope of this. So the slope of that is 1/3. So a perpendicular slope, I would flip my fraction and change the sign. So that becomes -3/1. Now when I'm graphing, -3/1 is the same thing as 3/-1, and I prefer negative y's. So this is going to be rise 3 to the left 1. So I'm going to rise 3 to the left 1, but I can also go down 3 to the right 1. And voila, graph my line. Okay, now I have a rectangle, and I want to know what happens to my rectangle when I double the units. So we're going to use 4x and 2x as the length and width. Okay, so if I double the length and width, my new rectangle would have 8x as the length and 4x as the width. So what happened to the length of my sides? They were doubled. Okay, so the length of my sides doubled. Now what would my area be? So the area of this rectangle, length times width, would be 4x times 2x, which would be 8x squared. Okay, my area here would be 8x times 4x, which is 32x squared. So what happened to my area? My area grew by a factor of 4, or quadrupled, however you want to call it. Okay, so to find the value of 21/9y, I first have to solve for y. So I'm going to take this equation and solve for y. I'm going to divide both sides by 7, and I get y equals 3/7. So 21/9y would be 21/9 times 3/7, which would be 63/63, which reduces to 1. Okay, so diameter of an E. coli bacteria is 5 times 10 to the 7th. Diameter of the fungi is 3.3 times 10 to the -6. How much bigger is the fungi than the bacteria? So I'm going to take 3.3 times 10 to the -6 over 5 times 10 to the -7. Okay, so that gives me, what does that give me? That gives me 6.6. Okay, so you can use your calculator on that. Okay, now we want to graph an inequality. So to graph this inequality, the first thing I have to do is solve for y. So I'm going to subtract 3x from both sides, and I get -2y is greater than -3x plus 8. Divide by -2, and I get y. Now I divided by a negative number, so I have to flip my sign. Negative over a negative is a positive, so that's 3/2 x. Positive over a negative is negative, so that's -4. So I'm going to start at my y-intercept, which is -4. My slope is 3/2, so that's rise 3 to the right 2. So rise 3 to the right 2, rise 3 to the right 2. And because I don't have an equal sign, that's a dashed line. Okay, so now this is less than, so I'm going to put my pen on my line and go down. Okay, so it'll look like that. Okay, so for this one, Jimmy made a table of these equations. So this gives me x versus y of the first equation, and then I have x and y from the second equation. Okay, So it says, what can I conclude about this? The first one says the system is made up of parallel lines. So if they're parallel lines, they have the same slope. -3 and 1/3 are not the same. So this is not true. Okay, then it says the system is made up of perpendicular lines. Perpendicular lines have opposite reciprocal slopes. I can rewrite -3 as -3/1. Then it's obvious that yes, those are opposite reciprocals. I flipped the fraction and changed the sign, so number 2 is true. Now it says the system has one solution at 3, -6. So if I look at my red dots, the point 3, -6 is on the first line. If I look at my green dots, the point 3, -6 is also on the second line. So this one is also true. Okay? It doesn't have an infinite amount of lines because the slopes aren't the same. It also doesn't have one solution at 3, -7. Okay? So this is not the solution. Okay? This is y from the first equation. This is y from the second equation. So that is not the point 3, -7. The system is inconsistent, means it has no solutions, which would mean they were parallel lines. We've already determined they're not parallel lines, so that's also not true. Okay, now let's do some EOC practice. Okay, so this graph shows us the amount of gasoline versus the number of hours. So it says the car uses 2 gallons of gas for every hour. So that's a slope. That's y divided by x. Gallons per hour would be the slope of this line. So what's the slope of this line? If I take this point and this point, okay, I'm going to rise 2, left. I'm actually rising 4, sorry. If you look at the axes, from here to there is actually 4, not 2, sorry. Okay, so I'm rising 4, and then right here, I'm going left 1. So that means I'm using 4 gallons per hour, so this is not true. Then it says the car uses 8 gallons every 4 hours, which would be 2 gallons per hour, and we've already determined that the slope is 4 gallons per hour. So this one is also not true. The car has a 16-gallon tank. Okay, we don't know this from this particular graph. We know that at time 0, when we looked at the tank, it had 16 gallons, but that doesn't mean the tank was full. I mean, if it was a Suburban, I have no idea how much gas a Suburban holds, probably more than 16 gallons. So all this means is at time 0 is at 16, but it could have been a bigger gas tank. So then it says the gas tank is empty after 4 hours. So if we look at this point, after 4 hours, we had no gas. So D would be correct. Okay, now let's look at this one. On this graph, we're looking at the altitude in feet versus the time. So F says the balloon reaches a maximum altitude of 2,000 feet. So the biggest Y that we see is indeed 2,000. So this one's true, but let's look at the others to see why they're not true. So G says the balloon's at 1,000 feet after 2 minutes. So after 2 minutes, I'm at 1,500 feet. So that's not true. Then it says it begins falling after 6 feet. Maybe it does, after 6 minutes, maybe it does, maybe it doesn't, we don't know. Then it says the balloon reaches 2,500 feet after 4 minutes. So after 4 minutes, that's at 2,000 feet, so that's also not correct. Okay. Okay, now we are going to find the area of this window. This would actually call the Norman window if you care. Okay, so we want to find the area of the window. So this is a semicircle, this is a rectangle. So the area of a circle is pi r squared. Okay, they want us to use 22/7 for pi. Now the diameter of this circle is 28 inches, which makes the radius 14. So we're going to do 14 squared, and if I multiply all that out, I get 616 inches squared. But that's only half of the circle. So the area of the semicircle is 1/2 times 616, which is 308 inches squared. The area of my rectangle is 21 times 28, which is 588 inches squared. And if I add those two together, I get 896 inches squared, which would be this one. Okay? Now, 46 is kind of a similar situation, except we're using volume. So we have a big, we have a big cedar chest. We're putting a little box in there, and we want to know after we put the box in, what's the volume of empty space. So the volume of the empty space is going to be the volume of the chest minus the volume of the box. So the volume of the chest is 2 times 2 times 4, which is 16. Then the volume of the box, is length times width times height, which is 6.75. This is all feet cubed. So the volume of the empty space would be 16 minus 6.75, which is 9.25. So my answer is 9.25 feet cubed. So I hope this has helped. Study hard, do great. I have complete confidence in you. See you later. Bye.